Hello students, this is lecture number 35. Okay. So, and we have almost finished this chapter, chapter number 9, and which is on 2D elasticity. Okay. Well, this chapter is not only about 2D elasticity, you can actually extend it to 3D as well. So, whatever you learned, you can extend it to 3D elasticity, but in our the syllabus has only 2D only. Okay. So far we looked at basically we have found this kind of equations. So, this is a K E tilde U E tilde equal to F E tilde. Yeah, so that is where this is the stiffness matrix, displacement vector, and this is a force vector, and size is 2n by 2n. So, let us write in yellow color 2n by 2n matrix, this is 2n by 1 matrix, and this is also 2n by 1 matrix. Okay. So, today we are going to extend whatever we learnt last time, we are going to solve the problems from the book. So, let us solve problem number 9.5. Okay. So, this we will use whatever we have studied so far in last 4 lecture videos, whatever we learned, based on that we will solve it. So, here the problem is something like this, which is given. So, this is a triangle which is given, and it is given this is 3 meters. So, this is 3 meters, here this one is 3 meters. Okay. And then there are forces which is perpendicular to on this boundary, and this is 15 Newton per meter. So, this is the T bar is given. Yeah, T bar is given like which is like this. So, it is not just T bar is equal to this one, actually this is T bar in this direction. So, basically we have to write like this T bar. So, T bar is equal to, or no, so let us write like T bar is equal to 15. So, we write 15 Newton per meter. However, this is in what direction? This direction is what? This direction is basically 1 here, 1 here. So, this will be 1 over root 2, and so this will be basically this will be 1 over root 2 I plus 1 over root 2 j. So, this is what direction it is. Yeah. So, T will also have the direction. So, that is what I mean to say. Yeah. So, this is what it is given. So, this is in Newton per meter square. Also, you can write of course, this is for the as per the problem, this is A, this is B, this is C. So, this is T AC. Yeah. So, on AC only we have like this, on others we have different. On others we have it says it is a roller here, meaning that it can take it will load vertically only, it will not take any force in horizontal direction. Similarly, we have a roller here like this one. Yeah. So, that means there will be a reaction which will be here there will be reaction which will be in horizontal direction, here it will be reaction in the vertical direction, this is what it means. Okay. Now, what else is given? Given it is x and y. So, this is x, this is y, which is like given like this one. Okay. So, 3 meters here, and it's like that. Okay. So, what else is given? Given is E. E is given to be 3 times 10 to power 11 Pascal, and Poisson's ratio nu is given to be 0.3. So, this you can assume this to be a plane stress problem. Yeah. So, assuming this to be a plane stress, we are going to solve it. Yeah. So, plane stress. Also notice that there is no body force. Yeah. So, we have B. Okay. So, B is equal to 0. Yeah. So, B is equal to 0. Yeah. Okay. So, no body force. So, all the stresses I mean the strain is caused because of this traction only. Okay. And there will be reaction traction here as well. Yeah. Okay. So, we are going to solve it. Okay. So, let us look at the displacement. So, first we will write down the I mean we will number the degree of freedom. Okay. So, here we need to number like this. So, first number the nodes. So, we have A here, B here, C here. So, we say 1, 2, 3, 4, 5, 6, right. So, we will do like that. So, we have we can so we can say like this one. This is U1x, U1y. Similarly, we have the next one which will be U. So, this is 1, this is 2, this is 3. So, U2x, U2y, U3x, U3y given, and then we are going to write what? We are going to write UE. Yeah, this is a displacement vector. So, start with displacement vector. So, displacement vector, what? This is UE tilde. Okay, and what is that? We have basically U1x, U1y, U2x, U2y, U3x, U3y transpose. Got it? Where what we see here is it is given that this is a roller here and here also roller. So, basically we have to put, so we have that really means this cannot move and this will have a roller which is in this direction. Similarly, this point has a roller in vertical direction only like this one. So, that means what? That means that U3y equal to 0, that means U2x equal to 0, U2y equal to 0, and that also means this U 1x is also equal to 0. So, only this U1 U1y will move, and here also this move this way, this point will be this move this way, this point will not move at all. Yeah. So, where we can say U1y, sorry, U1x, okay. So, U1x equal to U2x equal to U2y equal to U3y is equal to 0. So, all equal to 0, right. So, this is equal to, cannot move this way, 0, cannot move this way. So, both 0, here you cannot move this way. So, this is equal to 0. Yeah. So, only two things which can move. So, as we identified, and those are is U1y and U3x, these two. Okay. Now, similarly, we can find out the force vector. So, force vector again we have to calculate. Yeah. So, how to calculate? We do not know. So, from here these will be reactions basically. So, there will be a reaction. So, this will be F. So, we write like this, force vector, okay, and this we say this Fe tilde is equal to, we write it as say F1x, F1y, F2x, F2y, F3x, F3y, yeah, where these are the reactions. What you see corresponding to all these will be reactions, right. So, this will be simply these and these all will be reaction. Only this and this we have to find out. Okay. So, we can write equal to, let us write it like this. Since this is the reactions, we can write equal to R1x F1y, that we have to find out. Then we have R2x R2y, then F3x, that we have to find out, then R3y. Okay, R for reactions, reaction forces. So, basically the two, here there will be two reaction forces, one in x direction, one is y direction. Here reaction force will be in x direction only, here reaction will be in y direction only. So, yeah. So, the thing is we have to find out this, what is the value of these two. Yeah. So, okay. So, where we can find out the reaction forces will come because of this traction we have, right. So, we have T here. Yeah. So, okay. So, let us find out that. So, we have traction which is given like this one, and this is the value, let us call it T naught. So, T naught is equal to which is given as 15 Newton per meter. Okay. So, this is 15 Newton per meter. Okay. Okay, done. And here the we have, so we know that from here to here 3 meter, here to here 3 meter. So, length, this length is basically 3 root 2 meter. Yeah. This is what that is, meter square it is. Okay. We can take it as 1 meter depth. So, it will be n Newton per meter in that case. Okay. So, this is how this is the direction is, or n here in this case n is equal to 1 over root 2 I plus j. Yeah. So, which is perpendicular to this. Yeah. So, that is given here. Okay. Okay. Now, the we have to looking at this one, in fact we do not have to actually integrate. You can you know what to do. So, this is a constant which is a force which is distributed force. So, total force you can find out. So, this is without doing integration you can also find out. So, total force you can say total force will be equal to is equal to 15 Newton per meter square multiplied by 1 meter. Suppose this is a thickness, right, multiplied by length which is 3 root 2 meter, which makes it equal to 45 root 2 Newton. Yeah. So, this 45 root 2 Newton will be the total force, and hence half will go here and half will go here. So, this is equivalent to saying that we have half going here and half going here, and how much? how much it will be going here? So, here it will be going 45 over divided by 2, just 22.5 root 2 Newton in this direction, and 22.5 root 2 in this direction, and we know the angle is 45 degrees. Yeah. So, this is what it will be 45 degree, because we have this one, this angle is 45 degree. Yeah. So, because this is 3 and this is also 3, and hence we have this will be at 45 degree. Okay. So, so that means our reaction, if you look at it, that really means that the forces accordingly. So, there will be two components. So, that means here it will be two components. So, one component is this will be 22.5 root 2 multiplied by cos 45 degree. So, 22.5 Newton this direction. Similarly, here it will be also 22.5 vertical direction, right. Okay. Similarly, here also. So, here also it will be 22.5 Newton, and here also will be 22.5 Newton. Yeah. And so, if we see here, our numbering was like this. So, this is node number 1, 2 was here, this is 3, and this one is F3x, this is F3y, F1x, F1y. Yeah. Okay. So, we wanted to find out what? We want to find out F1y, F3x. So, basically we will have total. If we see that we are this is our forces which will have these values are reaction forces. So, and these are coming from the traction one. Yeah. So, I think we have to write like this is the total one. So, let us write like this one. So, this is a, let's call it, this is total forces. Okay. And this one has the, because of, so although we wrote like okay. So, let us write this will be reaction. So, this is just a reaction, the reaction only. Okay. So, if that is the reaction only, then let us remove this one. Yeah. So, let us make 0 here, 0 reaction, let us make 0 reaction. Okay. And let us add here, we also have to add plus the force which is coming because of the traction, and the force because of the traction will be coming here only. So, only these one. So, basically there will be a forces, these forces whatever we calculated, they are coming from there. So, we know that F3x is 22.5 now, F3y is, so this is which is coming. So, just to distinguish, we will say F3 Tx coming from traction, F3 Tx, F1 Tx, F1 Ty. Okay. So just to indicate that this is coming from traction. Okay. So basically we are going to write that, and we'll say will be 0 here, then F1 Ty, yes, then okay, it's not 0, so this will also have this one. So okay, just so let's write. So this will be F1 Tx, F1 Ty, okay, then 0 0 F3 Tx, F3 Ty, like this. Yeah. So this one coming from the traction, this is coming, these are the just the reactions. Yeah. So this is total force will be, if there is no body force here, so the body force component will not come here. So what I am saying is the total force will have two components. So one reaction forces, the other because of the traction. So this is because of the traction, this is because of the reaction only. So if we add, you will see this plus this will have reaction, this 0 plus this one, so we get just F1 Ty only. This one will be R2Y, this will be R2X here, this is R2Y, this will be F3Tx, this will be R3Y, and so on. So basically Fe, so you can write here Fe tilde will be equal to reaction force. So we write F. So this is what is F3Tx. This one is F3Y, F3Ty, F1 Tx, F1 Ty. Yeah. Okay. So we are going to write that. So F equal to, we have F1 Tx plus, yeah, plus we have R1x plus R1x, then next is this F1 Ty only, so this use different color. So F1 T, sorry, F1 Ty, okay, then third done, third and fourth R2x, R2y, so R2x, okay, then R2y, okay, then third done, 1 2 3 4, now remaining. So here, so this plus this one, so F3Tx, F3 so F3Tx in x direction, so F3Tx, F3Tx, okay, and then we have last one, which is R3y plus F3Ty, R3y, R3 3y plus f 3 ty transpose of that. Okay. So, this is what our element force vector. Yeah. Okay. And here you can see that we have reaction in all of them except two of them, and value we know that this is, and this value is basically 22.5 Newton. Yeah. So, we can write basically here this is 22.5 Newton, and this is also 22.5 Newton. Okay. Okay. So, once we have that, and next thing is to find out the stiffness matrix. Yeah. So, the stiffness matrix suppose, okay, one question, if suppose we had different T naught like varying, yeah, so then we have to integrate, and how we have to integrate? The same way as we did for the heat transfer problem. Only thing is there the q, we had the q dot n which was a scalar value. Here we have this as a vector value, and only we have to that means we can take the component, the x component, and we can treat it as a scalar value, and then we can integrate, we can find out. So, what I mean to say is, let us say we had here T which is given by Txi plus Tyj. So, at one time just look at how the Tx is. Okay. So, only Tx you can see what how the Tx is distributed, yeah, and then you do the integration like n, like ni xy, like in ni along this, along, let us say this is s direction. So, you say s nis, and this I means this point or this point, this what means multiplied by Tx, and we integrate this one, yeah, and this will give, if this is the ith, this is the ith node, then this will give what the value of Tx will be here, yeah. And similarly for Ty we can also, then we can have for the value here will be nothing but this as I plus nis Ty ds as j, that what we will get at this point. Two component basically, the x component is this one, the y component will be this one, means f x, basically what I mean to say is this will be equal to f I x, and this will be equal to f I y, yeah. So, now we do not have to write ij, because what I mean is like this one. So, what I mean to say is if you know that this will be given in terms of vector here. So, you have two components. So, you treat you just take Tx now, means what the x component, and then you integrate like this one, the way you did in the heat transfer, exactly like this one you do it, and whatever you get the value will give you the x component, means f I x whatever, and similarly you take the y components, you integrate like this one. So, you will get the y component here. So, basically you can also work with the this scalar value as well. as you did in case of heat transfer. Yeah. So, so basically the difference only is here it is vector. Earlier case it was a scalar, otherwise it is the same thing, we do the same kind of thing. Yeah, there is nothing different. Yeah. Okay. Okay, so now a stiffness matrix, if you want to calculate the stiffness matrix, how will we do? So, we know that K E is nothing but we have B, we write B tilde T D tilde B d omega, like this. Yeah. Okay. And this is that means this is integrated over the whole omega, and so this is K like this. Okay. And this one we can say equal to okay. So, ours is triangle which is like this one. Okay. So, how to find out B? First of all, this is 3 0, this is 0 3, like this is 0 0. So, we have to write the this is node 1, this is 2, this is 3, and we are going to write. So, this is the original, let us see the original one. So, this here, yes, is A B C. Okay. So, if you are using triangular element, then you know that we n1 will be equal to like this. So, we have 1 x y and then 0 1 0 0 and then this one 1 1 3 0. Yeah. So, 1 x y 1 x y 1 0 0 1 3 0 is equal to that means del n 1 over del x will be equal to, you can see that will be equal to, just we have 1 here, we will have 1 here, this will be 0 0. So, we will find just equal to 0 only. Okay, is it possible? Maybe possible. So, see here this okay, will be equal to 0 1. Oh, okay. So, if it is 1, then we have point here and we are going to area here, going to look at area here. So, this will be x y here like this one, and hence this will be 1 x y 1 0 0 1 3 0. Okay, that is correct so far. So, 0 1 0 1 0 0 1 3 0, and that means if we see here this one 1 multiplied by 0 multiplied by 0 equal to 0. So, del n1 over del x equal to, we get equal to 0. Okay. Now, del n1 del y will be equal to, so in that case so let us equal to what? So, let us look here. So, del n 1 over del y will be equal to 0 0 0 1. So, 0 0 1 1 0 0 1 3 0. 0 0 1 1 0 0 1 3 0, and that makes it equal to 3. Yeah. So 1 times 3, that's it. So we get as 3 equal to 3. Fine. Okay. Similarly, so this is done for n1, now n2. So again we draw like this, and here we have 0 0, which is 2, 1 we have 3 0, sorry 0 3, and this is 3, which is 3 0. Okay. Now n2 is equal to n2 will be here, and it will be like this one. So 1, this one, then here and here. So we get 1 0 3, right, then 1 x y and 1 3 0. Yeah, and hence del n2 over del x will be equal to 1 0 3 0 1 0 1 3 0, and hence will be equal to, so if take this one will be 0, if take this one automatically it is 0, if they take this one, then we have 3 times 0 minus 1, so becomes minus 1. So this is minus 1. Del n2 del y is equal to, so we have 1 0 3 0 0 1 1 3 0 is equal to, so again take this one, so 0 1 0 minus 3, so we get minus 3 here, second is 0, so 0 only, then we have 3 0 minus 0, so minus 3 only. Okay. Okay, so done. Now next, again we have like this, just for reference. So 2 0 0 3 0 3, so not 1, sorry, this should be 1 1 0 3 and 3 3 0, just like this. Okay, so here we get n2, so we go to n3. n3 is equal to, so 1 0 3, okay, then 1 0 0, and then 1 x y. Yeah, so this is for the third one. So this area of this basically. So this will be del n del n3 over del x is equal to 1 0 3 1 0 0 and 0 1 0, and that will be equal to, so if you take 1 it will be 0 only, 0 0 only, 3 you get 3 multiplied by 1, so becomes equal to 3. Del n3 del y will be equal to 1 0 3 1 0 0 and 0 0 1, and what do we get? We get 1 0 0 0 0 3 0, so we get all zeros, so equal to 0. Yeah. Okay. So basically we got this. The next one is to write the B basically. Yeah. So B we can collect. So B matrix B is equal to, so B has like this. So now we have 3 by 6 in this case. So 3 by 2n. So this is 3 by 6 we will have. And how we write, if you recall from the last lecture video, this will be del n1 del x 0, del n2 del x 0, del n3 over del x 0. Next will be 0, del n1 over del y 0, del n1 over del n2 over del y 0, del n3 over del y. Then we will have del n1 over del y, del n1 over del x, del n2 over del y, del n2 over del x, del n3 over del y, del n3 over del x. So this we studied in the last video lecture. So we know that what will be the value here. So we got all constants only, and in case of heat transfer problem also we had got constant B matrix, but although dimension was different. Okay, so okay, so we have 0, 0 and 3 because of the 1. So let us look at the first. So we will see this is 0, then we have minus 1 and 3, 0 minus 1 3. So 0 0 0 minus 1 0 and 3 0. Okay, now next one we have 3 minus 3 3 minus 3 0, 3 minus 3 0. Okay, so we have 3 minus 3, sorry, that is not correct. So 3 minus 3 and 0. Okay. Okay, so yeah, one thing is we also have to divide by the area. Remember that. So the B matrix in this case n1 n2 itself have some area there. So that we forgot. So hopefully everything is all right otherwise. So let us see. So this n1 will be this area divided by the area, and this divided by the area. So what is the area? Area is half 3 times. So we write here area. Okay, so n1 divided by area. Okay, so we get this equal to 1 over area is equal to 0. This get 1 over area, and hence 3 over area, 1 over 2 area, sorry, there will be 2 area, right. So 2 area, 2 area, 2 area. Okay, where 2 area is equal to nothing but 3 times 3 equal to 9 meter square. So 3 times 3 is 9 meter square. So 3 over 2a is equal to 3 over 9, so 1/3. So anyway, that we can write later. Here also N2 will be 1 over 2 area, and hence 1 over 2a minus 1 over 2a, yeah, and similarly here 1 over 2a, so hence 1 over 2a will be there, that will be common to all, 1 over 2a, 2a, 3 over 2a, 1 over 2a, so like this one. Yeah, so let us write it, this will be equal to 1 over 2a, yeah. So 1 over 2a is nothing but 1 over 9, so we write 1 over 9 here. Okay, so we got, okay. So what we are getting is 0 minus 3 and 3 years we got 3. So let us see, this is we got minus 1 in case and other minus 3. Here we got 0 and this case also we got 0. So let us make sure that this minus 1 and minus 3 are correct, yeah. So because this is symmetric, so all other two are okay, but okay, so let us see. So minus and minus 3, so we will make sure this is correct. So this is minus 1. So this is N2, N2 will be here, so like this one, so will be 1 0 3, okay, then second we will be 1 xy, then 1 3 0 del x, so this will be 1 0 3 0 1 0 1 3 0, and hence it will be 1 yes, see, I can see there was a problem. So what we see here, so see, if you take 1 and then 0 minus 0, so this is 0 only, 0 if you take 0 only, 3 we take, so 0 minus 1, so 3 minus 3, so this is not correct. Okay, so this will be, should be minus 3, and this why I doubted, because this is symmetric in x y if you see. So similarly our value should be like same in both the cases. So we have like in this case minus 3, so here also should be minus 3 only. So now this is correct. So in here we get 3, so and here we are getting 0, here we are getting minus 3 both the case, here again we getting 1 for 3, other for 0. So this is matching the pattern basically. So here we get minus 3. Okay, so now this is correct. Okay, now here we have to match, and for that we have to write here just this will coming from this one, this will come from here. So this from here, this from here, we do like that. So this is from here and this go from here to here. So 0, let us say minus 3 here, we get 0. Now this will come from here, so this will come from here, so minus 3, okay, and 3, okay, so we are done. So this is what the value of b is. Now it is divided by 9, yeah, so here we have 3, so this will also simplify later. So the idea is that we have already got B. Now next is D. This is B matrix. Now D matrix. D matrix, we know that this is E over 1 minus nu square and 1 nu 0 nu 1 0 0 0, and then here we have 2 1 plus nu over 2, yeah, where D E is equal to we have values given. So let us look at the here E is here 3 times 10 to the power 11 Pascal, and nu is 0.1. Okay, so this is 300 gigapascal basically. Okay, okay. Let's go back. Okay. So, 3 times 10 to power 11, 1 minus 0.3 square, and here we have 1, 0.30, 0.310, 0, and this is 1 plus 0.3 divided by 2. So, 1.3 divided by 2 equal to 0.65. Okay, so this is 0.65 like this. Yeah. Okay, so this is what the D is. Okay, so next thing is to find out the K. So Ke will be equal to B tilde T and D and B. Yeah, B. This is what will give you the K. So B will be okay, B is a 3 by 6, this is 3 by 3, and B transpose basically this gives you 6 by 3, 6 by 3. So K will be 6 by 6 matrix. Yeah, so this is how we can find out. And next thing, once we have that, now rest thing is just to solve, how to solve it. Yeah, so now of course this problem is bigger now, or hence you have the this kind of thing. So the equation is K E tilde U E tilde equal to F big F E tilde, where we know what the K is. Now we know what this is, we know what this is. We have the matrix system now. The only thing now is to how to solve them. That is the only thing remaining. Yeah, so that's how you can do. Notice that we have to write A area multiplied by area. So this is the area here, where area is equal to 9/2 meter square. Okay. So we have this one, but now we can also add the further details, especially knowing that only the free degree of freedom is what? Free degree of freedom is just this one and this one. Okay. So see here, so if you see the row number wise, this is row 1, this is row 2, 3, this is 4, this is 5, this is 6. Yeah, so basically what is important is what is the this row number 2 degree of freedom and number 5 degree of freedom. Okay. So we can no need to calculate all basically we just take number 2, so not row number, but in this case column basically. So we are interested in number 2 column and number 5 column. Yeah, and similarly the B transpose, then we are interested in number 2 row and number 5 row. Yeah, so we have 0 3 0 and 3 0 0 and 1 9. So basically what we are just interested in just regarding only these two. So we can write the small one, the reduced equation will be just let us say call it KR for reduced, yeah, multiplied by U reduced equal to F reduced, where U R has just the U 1 y and U 3 x only. Yeah, so only this will have, and F R will have the forces F 1 y, yeah, F 1 y and F 3 x basically, and which is equal to, as we know, this is 22.5 Newton and this is also 22.5 Newton. So we have that. So, that really that corresponds to, this corresponds to degree of freedom number 2, this is degree of freedom number 5, okay, like this one. Okay. Now, we have to find out this Kr, yeah. So, this Kr is equal to again number 2 and number 5 degree of freedom. So, we can write like this. So, we have here and we will have 1 over 9 will be there, and some equation here, and then we will have multiplied by this D matrix. Okay, so D matrix, this multiplied by this one. So 3, so this value is 1 minus 0.9. So 9 and 0.09 and 0.91. So basically this one is basically 3, 11, 0.91 and these values 1, 0.30, 0.310, 00, 0.65. Okay, done. Okay, so now this one we can have this there. So we are writing D here. So this will be multiply 3 multiplied by 11, 0.91, and here we have 1, 0.3. So 1, 0.3, 0, 0.31, 0, 0, 0.65, right, and then here we get the B reduced one. So what we are going to take, we just take the one which is relevant one from the B. Relevant is number 2 and 5 only. So this is important, this is important, yeah. Okay, so just to, this is number 2, this is number 5 which is important. So we have 1 over 9, 0, 30, 300. Okay, so so 0, 30, 300 multiplied by 1 over 9. So 1 over 9 multiplied and multiplied by area. Okay, so we also have to multiply by the area, and area is 9 over 2. So let's multiply 9 over 2 as well here. Okay, so what do we get now? So this becomes, so 9 cancels out. So we have 9 here, 9 times 2, 18, and like this one. So we get equation k equal to 3 multiplied by 11 divided by 18 multiplied by 0.91, and here this will be just transpose of that. So this is 3 by 2, this will be 2 by 3, 2 by 3. So we write 0, 3, 0, 3, 0, 0 like this. Okay, and now we have to multiply this by this by this. So we have this 0, 30, 300 multiplied by 1, 0.30, 0.310, 0065, and here 03, 3000, and this is easy to now actually do it, right. So, you see this first we can do it, this multiplied by this one. So, we get 0.9 here and so on. Yeah. So, this is also equal to 0. Yeah. Okay. So, here get this multiplied by this and so on. So, let us see. Okay. So, we can find out Kr very easily is equal to then this. So, we have 10 to power 11 divided by 6, 10 to power 11 divided by 6 multiplied by 6 multiplied by 0.91. Okay. Then let us see. So, now we have this multiplied by this one. So, with is this 0.9 simply. So, we write 0.9. Okay. Now, this multiplied by this one, this multiplied by this one. So, just 3, we get 3. This multiplied by 3. So, this one, this row, but we have multiplied by 0, 3, 0.930. So, 0.930. Okay. Second row we have so far we have done this one, this one, this one, this one, this one, this one, we are done. Now, second one, if you see, we have this 0 0. So, whatever multiplies here becomes 0. So, only this one and multiplied by 3. So, this becomes 3 0.90, 3 0.90. So, 3 0.90. So, that is what we get, and then the second one, second part 033000, 033000. Okay. So, we have this one. Now, we multiply this by this. Yeah. So, we get 2 by 2 matrix. So, equal to 10 to power 11, 6 to 10, 0.91. Yeah. And what do we get? So, now this multiplies to this one. So, what we get here is this multiplies 0, this multiplied by 0. So, this multiplied by this. So, only this is 3. So, first this multiplies to this, then this multiplies to this one. So, we get this only, all this becomes 0, this only, and multiplies by 3. So, we get 9 here, and this one we get 2.7. Okay. Now, what about this one? Similarly, this multiplied by this one. So, only this multiplies to 3 and this multiplied by this multiplied this one. So, only this multiplies to 3. So, 9. So, again this becomes 0. What do we get? We get this one 0.27 here. So, this multiplied by this one 0.27, and then this multiplied by this one, then 9. So, we get 2.7, 2.7, and you get 9 here. Okay. So, this is what we get, and this symmetric also, we expect this to be symmetric like this one. Yeah, it is done. Okay. And then we have the KR is done. So, now the equation is multiplied by, so so 10 to power 11, 6 times 0.91. So we can write exactly the value. So 6 here, 5.46. So 5.4 10 to power 11 over 5.46, 9, 2.7, 2.79 multiplied by u1 u1 y and u3x is equal to 22.5 and 22.5. Okay, so whatever we get, this one is meters. So now we have to just invert it. So what do we get? We get u1y and u3x will be equal to 5.46 divided by 10 to power 11. Then we have to divide by this also. So 9 square minus 2.7 square. So that's the determinants. So multiplied by 1 over 9 square minus 2.7 square. Okay, fine. And then we have inverse of that. So 9 and this minus 0.7 minus 2.7 minus 2.7. So inverse of that basically. So we have 9 minus 2.7 minus 2.7 and 9, right, and then you have 22.5 and 22.5. So this is what we get. Yeah, okay, which is equal to, so this is 5.46 10 to power 11 multiplied by we have here 981 multiplied by 1 minus 0.3 square basically. Yeah, so this is 9 square, this one. So I think this and this will be cancelled, and then we have here, so this will have 9, so 22.5 multiplied by 9.2.7, and this will be here also it will be same thing. So this will be also here 2.2.5 multiplied by, so multiplied by 9.9 minus 2.7, and this will be meters. So this is what it will be. So solution will be equal to, we can simplify, we can find out. So simplification 5.46 10 to power 11 and 81, and then this is 0.91. Yeah, okay, and here we get 22.5 in the both the cases, multiplied by 9 multiplied by 1 minus 0.3 0.7 basically, and then 1 will be equal to, so 99929 will be there. Here also we can actually we got this one by multiplying this one. So see, So we got this. So 0.91 multiplied by 6 is we got this one. So let's write here. So this one is 6, that's what we get, and from here this 9, we get 9 here. Okay, so our equation is straightforward now. So we get 6 multiplied by 22.5 multiplied by 0.7 divided by 9 times 10 to the power 11, yeah, and multiplied by 1 and 1, this is the meter. So this is what we get, u1y and u3x, yeah. Okay, so very we can simplify further, but here the this is how you got all these things, and once you get that rest you can find out, but for finding that you have to get the full K matrix, yeah, then only you can get all the other things. But this, since if we have to find out just u, we can find it like this one. All other things, as you know, all other things are just the linear algebra basically, yeah. Okay, so that is all. So in the next lecture we will look at 4 noded element. Okay, one thing you should remember here, that if you try to find out the strain, then what happens? Yeah, so strain, as you know, this is will be constant strain. So what I mean to say is, if ux, yeah, so if you know that a strain, how a strain you calculate. So let's say for this element you have to find out the strain, like means what, meaning this one, this equal to what, if you have to find out, this means this xx, epsilon yy and epsilon xy, which will be equal to del ux over del x, del uy over del y, and del ux del y plus del uy over del x. So basically we have to calculate this one, okay, and rest is all the relationship basically, yeah. So we know that let's say we have found out all this. So we have the displacement we found out. Yes, in this case u, all u are 0 except for this u 1y which we calculated, and here u 3x that we calculate. All others are 0. This is 0 0, this is 0, right, this is 0, yeah. So basically the n, we know that u tilde is n I u I tilde, this is summation, or basically what we mean to say is ux and uy is equal to n1 and then we have u1x u1y plus n2 u2x over u2y plus n3, yeah. So u3x u3y. Okay, now all in this case all others are 0, right. So we know that this is 0 here, this we found out, okay. So this is 0, this is 0, yeah, and this we found out, and this is also 0. So this is also 0, yeah. So our answer is very easy, right. So in this case what we get is simply this will be equal to like this. We got all 0 here, only n3 times this one is there. So we get n3xy u3x, and here will be n1 xy u1y. This is the only, actually this is ux and uy, yeah, and so basically ux and the ux is equal to, that really means that ux equal to n3xy u3x, and uy is equal to n1xy, right, and u1y. That's it. This value we got already, this value and this value in the previous page. This is what these values are, we got it here, and n1 and n2 we know. So basically exactly we can find out what is the value of ux and uy is. So n1 is n1 xy, that we know, that was is 1 xy, and then we have 1 0 0 and 1 3 0. So we know that, right, so which is equal to, so we can write it as, so we know that this is 1, this is 0 minus 0 is 0, x, 0 minus 0 is 0, 3 is 3 minus 0, so 3y, so this one is just 3y, and n3 xy is equal to, is okay, divided by 2a as well, yeah, so divided by 9, not to forget, so 1, so y over 3, yeah, and here also you have 1 over 9, and then you have 1 0 3 1 0 0 1 xy, yeah, so which will be equal to, so let us see, we have 1 here, 1 0 0 done, 0, so done, 0 0, and then we have x 0, so 3x, so we get 3x divided by 9 equal to x over 3 simply. Yeah, so that really means that we can write exactly now. So x will be equal to what it says. It says ux equal to n3 u3x, n3 is this, so is equal to x over 3 u3x, and uy is equal to y over 3 u1y, yeah. So this value is known, this value is known, but this is how it is varying, and from here we can find out values, right. So del ux over del x, will you get u3x over 3, and del uy over del y, you will get equal to u1y over 3, and all other things will be 0. So like there is no y here, so del ux over del y will be 0. So del ux over del y equal to del uy over del x equal to 0, yeah, and hence we can find out like these values, like this one is nothing but epsilon xx, and this is epsilon yy, yeah, and this plus this is epsilon xy, and hence we can say epsilon tilde is nothing but is equal to u3x over 3 u1y over 3 and 0 transpose of that, yeah. So this is what we will get, where u3x and this one, all these values we got already, and this makes sense. What it tells you, that what is the displacement in x direction divided by what is the length, right, what is displacement. So what it means, if you have to calculate the strain, how will you do it? So let us say here, so in x direction this one is fixed, so whatever displacement here at this this node, this displacement, because this is fixed, this displacement divided by the length from here to here should give you the strain in the direction. That is what this strain is. Similarly, in this side, what is the displacement in y direction, which is this, divided by this length, which is 3, this is this strain, and then 0 is the basically there is no, what we see in this case, there is no shape change, it remains the same triangle basically, only thing this stretches this way, this stretches this way. So, hence there is no torsional strain, okay. So, hence this will be 0, that is what it tells you. If you want to find out the stress, you you can do it. How you do? Sigma equal to d tilde and epsilon, you get the stress automatically. So, you know that. So, this is how you calculate the strain, and what you see here, strain is constant because u3x and u1y both are constant. These are the values we got it. So, a strain is constant, and hence it is called constant strain triangle. Okay. So, this is called constant strain triangle, CST, because a strain is constant because of this. Okay. So, that is all for this one, for this video lecture. So, we will talk about the 4 noded element in the next one, and after that the chapter will be finished. So, we will solve one of the example problems there too.